In our last lesson, we went over graphing lines, linear equations, given that the linear equation was given in slope-intercept form, and that is the y equals mx plus b. If you remember, I was warning you to go ahead and plot this last term first on the y-axis because that is the y-intercept. That anchors the equation to the xy coordinate system. So you plot that first, and then from that point, you count out the slope. So for this example down here, I kind of labeled what you need to do first, second, and third. First thing you need to do is you need to plot 3 on the y-axis. So we plotted 3, and then from that point, we started to count our slope, and we always start with the numerator. If that is negative, I want you to count that down. So always count your negative in the numerator. If it happens to be a negative slope, you would count down. In this case, we counted down 4, and then the bottom, the last step that we need to do is count out the change in x, which is 3 units to the right. So we counted that to the right. Got our second point, and then we were able to connect those 2 points to make a line. I wanted to review that before we go on to our next work, which is this right here, where we're looking at different equations, and we need to plot these. So we recognize that it's going to be a linear equation because you see 2 variables, an x and a y, but this is not in that y equals mx plus b format, which is what we want if we're going to graph this. But you know, we've got skills from back when we were solving single variable equations. You went about the whole process of trying to isolate the variable. You're going to think the same process, except this time you're going to think about, what do I have to do to isolate y on the left side? So you're going to go through that isolation steps. So I'm trying to isolate y. That means I have to get rid of this term here, the negative 7x. And I do that by using its additive inverse. So I'm going to add 7x because that'll cancel that out. If I add 7x to one side, I have to add 7x to the other side. Draw my computation line. These cancel out. That's why that worked. Bring down my 5y is equal to, and I want to write this in order, y equals mx plus b, so I want that 7x to be next. And I don't have to write the positive. I can just write 7x, it's assumed that is positive, minus 20. Okay, we're on our way. We still do not have y isolated. This is 5 times y. We have to think about, how do I undo multiplication? And I do that by dividing. So if I divide that term by 5, I'm going to have to divide every term by 5. So that eliminates. So we have y is equal to 7/5 x, and then we have to simplify this fraction here. 5 goes into 24 times, and this is going to be a negative 4. So now we have it in y equals mx plus b format. So we can go ahead and graph that last part, the negative 4, on the y-axis, because that's where it crosses the y-axis. So I come down here and I plot 1, 2, 3, 4. I went down 4 units. And now I'm going to come back and plot my slope, which it's 7. The numerator is change in y is 7, so I'm going to count up 7. So 4, 5, 6, 7. And then my change in x is 5, so I'm going to count over 5. 1, 2, 3, 4, 5. So there I've got my second point, and I can go ahead and connect those with a line. So now we can see that we don't necessarily have to have it given to us in y equals mx plus b format. We can go ahead and do our algebra, employ our algebra skills to make that happen. So we're going to continue on with this next one. Now the deal here is I've got an x and a y variable on the left side, and I've got an x variable here. But back to what we need to do. Our goal is to isolate y on the left side. So I am going to go ahead and try to get this y term isolated by subtracting 3x from each side of the equation. And I'm lining up the 3x underneath the 9x because those are like terms, and I'm going to collect them. These eliminate, so now I have negative 2y is equal to 6x minus 8. And I'm going to continue on trying to isolate and get y by itself. And I do that by recognizing that this is negative 2 times y. We undo that multiplication with division. So I'm going to divide that term by negative 2. If I divide that term by negative 2, in order to maintain this balance, I have to divide each term by negative 2. So this is something we've done before. So y is equal to, and then negative 2 goes into 6 3 times, and so that would be a negative 3x, and then negative into negative is going to give us positive 4. So again, you're seeing that you've got to have your skills with multiplication and division, addition and subtraction of positive and negative numbers under your belt. So again, I'm going to go ahead and plot this one. We're crossing the y-axis at 4, so this time I'm going to count up 4. 1, 2, 3, 4. And then this is a -3, and I want that to look like a slope, so I have to write that -3 over 1, so I can see that there's -3 change in my numerator, 1 change in my denominator, which is the x variable. So I'm going to count down 3. 1, 2, 3, and then over to the right 1 unit. Again, I'm going to use my straight edge to make my line. And we can see that we had a positive slope here, a negative slope here, and that all kind of jives, makes sense with everything that we've noticed about signs with our slopes. So in this next one, we need to isolate and get y by itself. I'm going to start by subtracting 3x from each side. That eliminates, so now I have 4y is equal to -3x plus 16, and I'm going to divide each side by 4. Or each term by 4. I've got y is equal to -3/4 x. 4 goes into 16 4 times. So this time we're starting at the origin, counting out our 4. So we're going to count up 4 because that's where it crosses the y-axis. That's step 1. Step 2, we're coming back to that numerator. That numerator is indicating a change of -3 in our y variable. So I'm going to count down 1, 2, 3, and then our denominator is indicating a change of 4 in our x variable. So I'm going to count 4 along or parallel to the x-axis. So 1, 2, 3, 4. And draw my lines and get them connected. Okay, so we've had a lot of practice with graphing linear equations. Whether or not we have it in y = mx plus b form or not, we now know how to get it into y = mx plus b form if we need to. But let's say we need to go backwards. Let's say we now are given some information and we need to write the equation of the line. Well, this is going to be a piece of cake. We just know that we have to get this in y = mx plus b format. So I can go ahead and, this is my m, my slope is my m, and this is my b. This is my slope, my y-intercept. So y is equal to 3x, putting in my slope for 3, or 3 for slope, plus 1. And then I can go ahead and I'm just going to graph all of these just because I feel like we need as much practice as we can on that. So I'm going to plot my line. I've got my y-intercept of 1, so I'm going to go up 1. Oh, you know what? I didn't point something out here. Up here on my equation, my slope is 3. I need it to look like that change in y over change in x, so I write that over 1. I know I did that elsewhere, and I don't think I made a big note of it. So anytime you need your slope, you're given a whole number, you can write it in fraction form by writing it over 1. So we do the same thing here. Sorry, I'm getting kind of out of order here. So I've plotted 1 on my y-intercept, plotted 1 on the y-axis. And this time I'm going to count up 3 units, so 1, 2, 3, and over 1. And there's my line. So that graphing part is nothing new. It's taking this information here. So this time I have a slope of 0 and a y-intercept of -5. So that's basically saying y is equal to 0x minus 5. That goes away. In a previous lesson we talked about this situation. When you have y equal to some number, you know that that's a horizontal line. So we know this is going to be a horizontal line. One way you can kind of remember that, it's kind of ducky, but you've got y is equal to some number. If you turn that y upside down, it's kind of like a cursive H. Funky way to remember it, but whatever. Okay, so this is going to be a horizontal line through -5. So I'm going to count down to -5. 1, 2, 3, 4, 5. And draw a horizontal line through there. Okay. Last one, and this is very typical where you're just given the slope, very much like the first one. Slope is a fraction, and we've got our y-intercept, so we're going to plug everything in. Y is equal to -2/5 x plus 3. And then plotting that again, we're going to plot at the end, up 3, 1, 2, 3. Make our point there. This time our slope is -2/5. I'm going to count down 2 and to the right 5. 1, 2, 3, 4, 5. And there's our line. Okay, one thing I want to point out is in the next lesson, I'm hoping to get to these linear applications where you're reading a word problem and you have to recognize what your slope is. From the word problem, you would need to recognize that the slope is going to be some rate of change in your word problem. So you recognize that rate of change and know that, hey, that's my slope. That's my unit change from one unit to the next. And you're going to recognize in your word problem that you're going to have some fixed amount. Either it's a cost or a starting point or something. That's your y-intercept. So I'm just trying to give you a heads up on that you get your bearings from the word problem, but what you're trying to recognize is the slope and the y-intercept. So you can create your equation, possibly graph it, and then also use that equation to maybe calculate other points of interest from your word problem. So we're heading that direction. I have a couple things that I wanted to wrap up in regard to all of that, and I think this part, what I did is I went ahead and did the work on it, and then I'm going to discuss it. I'm going to talk about parallel lines having equal slope with different y-intercepts. In other words, we've talked about that before, that if I wanted to find a parallel line to this point, this equation right here, it would have the same slope of -3. It would just cross the y-axis at a different point. Let's say that it crossed the y-axis at -1. I would count down 3 and over 4, and I would be able to create another parallel line. And I'm just going to, lightly draw that in there so that you can see, and just trying to prove it to you, that parallel lines will have the same slope. These both have the same slope of -3 over 4. They just cross the y-axis at different points. Okay, so we're going to take a look at some work that I did here. Perpendicular lines have slopes that are negative reciprocals, and I'll get to that next. But we're going to look at each of these equations. Now, we've got some work that we had to do here. This was not in y equals mx plus b format, and we can't analyze things until we get it in that format. So I went ahead and added 3 to each side of this equation. That cleared that out. So now I had y isolated, and I have 3x plus 1. And if I want to, I can write that over 3 over 1, so I'm recognizing slope there. This original problem was that the y was not isolated. We could isolate that by dividing every term by -2. So we ended up simplifying this to get y is equal to -3/2 x minus 1. Well, they are not the same slope, so these two are not going to be parallel, nor are they going to be perpendicular for that matter. But here I am with the next one. I need to, again, isolate y. So I divided everything, or I'm sorry, I subtracted -3x from each side. Now I have -y is equal to -3x minus 5. But that y is still not isolated. I need to get that isolated by dividing everything by -1 to get this number here, or this equation here. Similar thing here, getting y by itself, so we can recognize that we have the same slope here, here, and here. So these other 3 are going to be parallel. When I'm looking for perpendicular, I'm looking for slopes that are negative reciprocals. In other words, the signs are different and they're a flip of each other. So I went through all of the work of, getting them in y equals mx plus b format. So now I'm looking at my slopes, and I can see that these have different signs and they are the flip of each other. So I know these two are perpendicular, but none of the others have that complete pattern. We might have a change of signs, but we do not have all of what we need. Okay, and coming down here, I think my screen is just a little big. Okay, so coming down here, we're looking at what happens when we're graphing linear inequalities. And inequalities look very similar, except we have this greater than or less than, or this, greater than or equal to, or less than or equal to, or less than or greater than. That's going to change how the graph looks. But we go through the same work. We're trying to isolate and get everything in y equals or greater than, or whatever it might be, whatever our symbol is in here, whatever our inequality, mx plus b. So that's our goal. So I went through that on both of these and got both of these in that y equals mx plus b format. Now we just have to figure out how the inequality impacts that. So I'm going to go ahead and graph this first one. This one crosses the y-axis at 3, so I'm going to count up to 3. Going to count out my slope, which is down 3 and over 5. We're probably getting sick of this format already. Because this is a solid line here, this is less than or equal to, that means it includes my line. So I'm going to make a solid line here. Now my question is, which side do I shade? If I plug in 0, 0, the point 0, 0, that's going to be my easiest one to plug in. So if I plug in -3/5 times 0 plus 0, this cancels out, and I'm asking myself, is 0 less than or equal to 3? And it is. If that's a true statement, wherever that is, that's where that's 0, 0. I'm going to shade that side of my equation. So basically, all of these points over here are solutions to this inequality. Okay, same approach down here. I've got it in y equals mx plus b format. But I want you to notice that, just reminding you that when you've got inequalities, you need to be aware when you are dividing by a negative number. What I did is I actually got to this point and I decided to write it out a second time so that you could see I'm dividing each of these terms by a -5. Because I'm dividing by a -5, I change the inequality from greater than to less than. But then I continue on just like I did before. I'm going to be looking at plotting. It crosses the y-axis at -3, so I'm plotting that. Coming back here, plotting up 3 and over 5. So I have a similar point there. But this time when I go to draw my line, I'm recognizing this is less than. It's not including the line. So I'm going to draw a dashed line to communicate so that my graph is communicating that this is a borderline, but it doesn't include that boundary. Then I'm going to plug in 0, 0, just like I did before, and I would end up, this would drop out. 3/5 times 0 is 0. So I'm checking. Does this check out? Is 0 less than -3? And no, it is not. So I'm not going to shade that side. I'm going to shade the other side. So the solution set is all the points on this side of this inequality. Okay.